Another simple question related to the ppm calculation. This question asks us to calculate the maximum possible HCN content in air without being harm to human. So it says that the maximum possible mass of HCN in 1 cubic meter is 300 milligrams. And the density is given. So if the concentration of hydrogen cyanide gas exceeds 300 milligrams per cubic meter in air, would be toxic to human body. What is the maximum amount of HCN that can be present in the atmosphere without being critical to human in ppm? And the density is given. The amount of HCN present in air is actually limitless because we cannot think about the amount, the volume, which we need to consider. So it says that it is limited. It says that to calculate the amount in 1 decimeter, in meter cube, in 1 meter cube. And the mass of 1 meter cube is given as 1.2 kilograms as the density. So first we need to know what really this ppm unit is. ppm is called the parts per million. If you get something, the 1 million of particles in a given sample, out of that, how many particles available in the sample that we consider. Because of that, we are not in a position to count the particle at all time. We can get it as a mass. In this particular question, we have to calculate the number of milligrams present in 1 meter cube. So ppm, parts per million, can be expressed like this. The mass of component or constituent, in our case it is HCN, in milligrams divided by the number of kilograms. Mass of bulk or the sample in kilogram. Why it is 1 kilogram here? See, the mass of 1 kilogram means 1000 grams, or 1000 into 1000 milligram. That is 10 to the power 6 milligram, 1 million of milligram. In 1 million of milligram of the sample or of the bulk, how many milligrams of the constituent or the component we consider is present? So then we can simply say the number of milligrams of the constituent present in 1 kilogram of bulk. Here we have to consider only 1 cubic meter. Why? The number of milligrams of the HCN in 1 cubic meter. Here the density is given for 1 cubic meter. Then in 1 cubic meter, that means if you get the 1 cubic meter of that bulk, the mass is 1.2 kilogram. We can easily substitute these values in this mathematical relationship. The mass of the component, that is mass of HCN in the sample, the maximum possible amount in the sample is 300 milligrams. As we consider 1 cubic meter, We can just put milligrams or with the volume unit. Then the mass of the bulk or the mass of the sample. As we consider 1 cubic meter again, it is 1.2 kilograms. Then this will cancel. 300 divided by 1.2 will be 250 milligrams per kilogram. So we can write it as 250 ppm. In addition to this question, we have another way of calculating the ppm. The above given relationship, mathematical relationship, can be used for anything. But if you consider solutions, normally we don't measure the liquid or aqueous solution in kilograms. Instead of that, we use volume in liters, milliliters, cubic, decimeters, etc. So when we consider the dilute solutions, the density of dilute solutions in most of the cases we considered as the 1 gram per cubic centimeter. Density of the solution considered as 1 gram per cubic centimeter. That is exactly equal to the density of water. So for dilute solution, we assume that the density of the solution is equal to density of water. So if I consider 1 decimeter cube, it contains 1000 cubic centimeters. Therefore, the mass can be taken as 1 kilogram. So instead of mass in kilograms, we can use the volume in decimeter cube. So ppm can be rewrite as mass of the constituent in milligrams divided by the volume of sample in decimeter cube or in liters. By using this also, we can calculate the concentration in ppm.